Pre-calculus, the average gradient generalized. When we talk about the gradient of a curve, we're referring to the gradient of the tangent to the curve at any particular point, a line touching the curve. Let's take an example. F of x equals x squared. We have 2 points, A and B. The values of A and B, the x values, are 1 and 1 plus h, meaning, of course, that that distance there is h. Get the y values of A and B. Well, when x is 1, substitute, we get the y value. When x is 1 plus h, substitute, we get the y value. Find the average gradient from A to B. Well, that's the gradient formula. yb minus ya over xb minus xa. Change in y over change in x. And that simplifies to 2 plus h. Now, what is h tending to as b approaches a? So as b goes towards a, notice what's happening to h. H is tending to 0. As B reaches A, let's have a look at that again. As B reaches A, this line becomes a tangent. Notice that when B is up there, there's the line. Now, as B reaches A, this whole line turns, and we end up with a tangent to the curve. Calculate the limit of the average gradient as h tends to 0. The reason why we're finding the limit is that we cannot find the actual value, because when b and a are at the same point, we're going to be dividing by 0. But we can find the limit. So we've already found that there's the average gradient from a to b. Now as b reaches a, h is going to tend to 0. So it means we're finding the limit as h tends to 0 of 2 plus h. And that gives you 2 plus 0, which is 2. What's the gradient of f of x at x equals 1? Well, the gradient at that point is the gradient of the tangent. Here's the gradient of the tangent. The limit of the average gradient as h tends to 0. Let's summarize that. Just keep it in mind. This is the same question. We're just putting it in a better form so you can see everything. Right, calculate the y values of the points. There they are. We've substituted. Find the average gradient. Change in y over change in x. There we are. Change in y, that y value minus that y value over that x value minus that x value. Simplifies to 2 plus h. What is h tending to as b approaches a? 0. Calculate the limit of the average gradient as h approaches this number, as h approaches 0. So we substituted 0 for h and it's 5. What is the gradient of f of x equals x squared at x equals 1? Well, we're going to take that limit. Let's have some examples in an exercise. Try them yourself. The answers follow. At x equals 2. So we're going to follow the same patterns now. We're going to have x value of a is 2 and b is 2 plus h. So therefore, I'm going straight to this limit. I'm finding the y value. There's the x values. There we are. 2 and 2 squared. And the y value 2 plus h and 2 plus h squared. Simplifying we are, and the limit as h tends to 0 is 4. Same process on x equals 0. So we have 0 and 0 plus h. And the limit of h as h tends to 0 is 0. X equals -3, so we're going to have 2x points, -3 plus h, which means we're going to have -3 all squared and -3 plus h all squared. Then we're going to take the -3 plus h all squared, subtract the -3, over -3 plus h, subtract the 1, the average gradient. Here we are, -3 plus h all squared, subtract -3 squared. That's the difference between the y values over the difference between the x values. Simplifying, here we are, we get -6 plus 9h. Substitute the h equals 0 in there and we get a number, so that limit is fine, -6. Oh, it's a 4-star general. Now what we're going to do is, instead of having a number for x and then the h, I'm going to keep x as x. And I'm generalizing it. So give the y values of a and b. Notice we no longer have y equals x squared. We've got f of x. So therefore, if that's x, this here is f of x. If that's x plus h, then this here is f of x plus h. Find the average gradient of f from a to b. Well, we're going to take that y minus this y over that x minus this x. Now that we cannot simplify anymore as long as we don't know the function, but that we can simplify. So therefore, on the bottom line, we're going to have just h. There's a formula for the average gradient of a curve. So now to find the average gradient of each of these. So I'm going to find f of x plus h. I'm going to put x plus h instead of x, minus, and then f of x all over h. So now f of x plus h, put x plus h instead of x, 3 times x plus h, plus 4. That's how we get that. Minus f of x. So minus, well, there's f of x, but be careful, put it in brackets. All over h. And we simplify. There's the average gradient. Pretty much what we should expect. Have a look. It's a linear graph. It's a linear function. The gradient is 3. Always 3. It's a straight line. Well, the gradient ended up being 3. F of x plus h. So we're going to put x plus h instead of x. So we'll have 3 times x plus h squared. Minus f of x. So we're going to have minus 3x squared. All over the h. Now it's algebra. Multiplying out, simplifying, common factor of h comes out, and we can cancel. There is our average gradient. Oh, getting complex now. We're going to put x plus h instead of x. So we're going to have an x plus h squared minus 3 times x plus h, plus 2. Minus f of x in brackets. Now we'll take away the brackets and simplify. Notice the sign change. Common factor of h. H is cancelled, and that's our average gradient. For fractions, oh dear. X plus h instead of x, so we'll have 4 over x plus h, minus f of x, just as it is there. Now there are 2 ways to do this. We can find a common denominator on the top line, x times x plus h. What's x plus h gained? It's gained an x, so the top is gained an x. X to there has gained an x plus h, so the form has gained an x plus h. Or, for those of you who know about what I called in earlier videos cancelling up, we can say, well, let's multiply top and bottom by x plus x times x plus h. There we are, x plus h, x plus h. We're really multiplying by 1, but the good thing about this, when this multiplies those two, this x plus h will cancel, leaving 4x. And with the green one, the x's cancel, leaving 4 times x plus h. Bottom line, hx times x plus h. Or we carry on with this one. Notice that that x plus h has gone to the bottom. It's not too bad because there's not a fraction below. And simplifying, h's can cancel. That's as far as we can go with that one. Some exercises. Pause, try them yourself. Blue, x plus h instead of x. F of x squared, I've seen that before. To x plus h. Remember the brackets when you're doing the f of x. So there we are. We've taken x plus h and we substituted instead of x. So instead of x squared, x plus h squared. Instead of plus x, it's plus x plus h plus 5. Minus f of x there as it is in brackets. To x plus h. I've seen that before. Don't really have to have that in brackets because this is a bracket in itself, but that's fine. If f of x equals 3, that's a constant. If f of x is equal to 3, f of 1 is 3, f of 2 is 3, f of a is 3, f of x plus h is 3. So therefore f of x plus h is just 3, minus f of x, which is 3, giving you 0.